Hi, I'm Daniel Bogdanoff, and every year we do a massive giveaway. And if you don't know, this year's event is already underway. You can sign up now at the link in the description and the pinned comment. Starting Monday, March 2nd, we're giving away over $300,000 worth of test gear. We'll draw winners right here on this channel. Hi, my name is Daniel Bogdanoff with Keysight Technologies, March 7th. So we're gonna give away, it is the official end of Scope Month. Since it's St. Patrick's Day, you are tiny.
I'm actually quite tall for a Scopercon.
Go find Daniel. If you can find these cutouts, Wave 2018. Hi and welcome to day 11 of Wave. Hi and welcome to Wave 2019. I'm Daniel Bogdanoff. You could win your choice of a scope, a network analyzer, a DMM, all kinds of gear. We're actually giving away 50 of these, but there's more than just a giveaway. We'll go all out and bring you a tech tip each day that digs into an engineering best practice for using test gear. So even if you don't win a piece of gear, you're still a winner because you get the greatest prize, knowledge. But we're also giving away 11 prizes a day, so your chances of winning are pretty darn good. Day 1 will be live streamed on March 2nd, so check the description for a link to that video as well. And make sure you're subscribed to this channel so you don't miss it. In the last 5 years, we've done close to 100 tips, so I thought I'd take a moment to share 5 of the crowd favorite tech tips from the vault. The first 3 are from last year, but we went back in time a little for the last 2. First up is what is probably the most commented tip from last year, where we debunked a fake news 9900 milliamp hour battery. Take it away, past me. So Bill found a 9900 milliamp hour battery on eBay. We don't think that's possible, so we broke out the power analyzer to see how this battery holds up. Hi, I'm Daniel Bogdanoff, and I'm joined by Bill Griffith, our power expert, who drove down from Loveland in the snow for a couple hours just to test these 18650 batteries with us. We're gonna do a capacity test on these batteries to see if they hold up to their rated specs. 18650 batteries are extremely popular in designs, mainly because of their energy density. These batteries use 6 common chemistries that all offer different trade-offs, and today we're gonna look at 3 of them. In all of them, metals are mixed with lithium ions to create batteries with unique characteristics. So Bill, what batteries do you have for us today?
We have a couple batteries. First, we have a battery that mixes aluminum with it to get higher capacity.
Okay, and these would be used in things like electric cars and laptops or e-bikes, that type of thing.
Absolutely.
And what else do we have?
The second battery we have is mixed with magnesium, and it gives us the ability to have an amazing discharge. It actually can output 20 amps.
20 amps. So that would be like power tools and something that requires, a lot of power all at once.
And the third battery uses magic.
Magic. So I need to find me some of that magic battery. Why do we say it uses magic?
Our 2 industrial batteries, these use some of the best technology on the market, has 3,400 milliamps hours of storage. Our other one has 25 milliamp hours of storage, while our magic battery actually claims to have almost 10,000 milliamp hours of storage.
Okay, so 10,000 milliamp hours of storage we don't necessarily think to be necessarily possible. That's almost 3 or 4 times each of these other 2 batteries.
You're exactly right. Triple the one, 4 times the other.
So one of these is not like the other, but we're engineers, so we want to prove it. So Bill, how are we going to test this magic battery?
We're going to use our new E-load, which is inside of the N6705C, and we're going to set up to do a constant discharge on the battery. We're going to see how long it takes, and by knowing the time and by knowing the current we're drawing, we can calculate its capacity.
So we're using a constant current mode, but with E-loads, you can also set it to be constant voltage, constant resistance, and constant power modes depending on what you're testing.
Correct.
And then to test these batteries, or to test any sort of battery, normally you would hook this up to a jig like this, and then hook up a DMM, draw current from it, and record that DMM data with a DAC. But with a power analyzer, you don't have to, right?
Correct. The new E-load actually has a precision measurement system built into it, so it makes very accurate measurements all by itself.
Okay, cool. So let's get started. In the interest of time, we went ahead and tested the first 2 batteries, and Bill's going to hook up our magic battery and see what we find out. So Bill, tell me a little bit about the test jig that we have set up.
This is a 4-wire test stand. So the idea is that we have the current going through the heavy wires, and then we have some other wires that will actually make the measurement. So we can make a very accurate measurement with our 4-wire test stand.
So we can do the discharge through the heavy wires and then actually measure what's happening through a separate set of wires.
Correct.
So Bill, what did we find out about the other 2 batteries?
Well, here are the plots. The 2,500 milliamp battery and the 3,400 milliamp batteries, the voltage drops as the load starts to draw the constant current, with a pretty significant drop at the end. It took about 5 to 7 hours for each of the tests. which is why we ran them in advance.
Okay, so this test did not last 20 hours. It only ran for 1 hour, 40 minutes, which translates to less than 900 milliamp hour capacity. That is 10x less than the advertised rating.
Yeah, it was too good to be true.
It was. We really wanted it to work. But this is just a simple test, but having good battery data is crucial. You can't just trust the specs on your battery. Other tests you should consider running are life cycle testing, impedance measurements, storage capacity tests, and discharge rates versus capacity, all of which you could measure with an eLoad. Thanks for watching. If you want to learn more about using eLoads, check out the ebook in the description that Bill wrote, and also make sure to subscribe to the Keysight Labs YouTube channel. See you next time. Next up is this DMM video that explains the difference between counts and digits. The question was, what's the difference between the number of digits for a DMM and its count? For example, the 34470A that we gave away last week is a 7.5 digit DMM. The one we're giving away today is spec'd as a 3.5 digit multimeter. Sometimes though, instead of it being specified as digits, you'll see it specified as counts. So why would you use one or the other, and how do you convert between the two? Well, they both spec the resolution of a DMM, and the difference is really just verbiage, but it can be very confusing. The confusion often lies in the fact that, and this is really important, not all digits on a DMM go from 0 to 9. Often the leading digit can't go any higher than 1, and sometimes it can go no higher than 3 or 5, and this is due to the internal architecture of a DMM. So if we're talking about a 3.5 digit DMM like this one, the 1/2 refers to the first most significant digit, and the 3 refers to the quantity of trailing digits. So the first digit can typically be 0 or 1, and the other 3 digits can be 0 through 9. This would mean that there are 2,000 possible states that the DMM can read, or 2,000 counts. It ranges from 0000 to 1999. The count spec is simply the quantity of possible readings on a given DMM. If this were a 3.75 digit DMM or a 3 3/4 digit DMM, the first digit could then go from 0 to 3 or 0 to 5, depending on the manufacturer, who you talk to, and what the marketers at that company ate for breakfast that day. It would then be a 3,000 count or 5,000 count DMM. So this is a 3.5 digit multimeter, but it actually goes up to 6,600 counts. So the lesson here also is that you should always check the datasheet before just assuming anything based on a digit value. So you can see why this might cause some confusion, and hey, why even use fractions at all? Well, that's what's been used historically, and depending on who you ask, that's what most engineers understand. It's also worth pointing out that the counts can be different depending on what DMM function is being used. This leads into a discussion about DMM measurement speed, or how many readings per second it can make, and DMM resolution and accuracy, which is basically how specific a measurement can actually be on a DMM, but that's a topic for another video. Third, we'll jump over to Aaron, who walks through Bode plotting with an oscilloscope. Not this oscilloscope, obviously.
If you're working with any sort of amplifier, filter, or power supply, you'll have to analyze how your device responds to various input frequencies. There are many cases where you might find certain input frequencies cause your device to malfunction, which of course needs to be resolved before the device is in the hands of a customer. The frequency response analysis capability, also known as FRA, allows you to analyze how your device is functioning in the form of a Bode plot. This enables you to view the gain and the phase of the input signal versus the output signal. The FRA application works by using the oscilloscope's built-in waveform generator to perform a frequency sweep at the input of your device. For this example, we're just going to test a very basic bandpass filter. So the waveform generator gets hooked up to the input of the device along with channel 1. And channel 2 should be connected to the output. This way the oscilloscope can compare channels 1 and channel 2 to calculate that gain and phase information. Now in the Analyze menu, we can navigate to FRA, and in the Setup and Apply menu, you can customize the settings like the sweep range and the number of points per decade. Once you have that all set up, you can just press the Run Analysis button. We can see channel 1 actually sweeping on screen as it should be, and the data plotting on the Bode plot in the background. So this blue trace represents the gain, and the red trace represents the phase. So with the Bode plot, we can see the frequency sweep range along the x-axis and the gain and phase data along the y-axis. And now you can analyze each of the data points with the markers on the chart, or you can also go into this table. You can also play around with the scaling if there's anything that you want to zoom in on to take a closer look at. If there were any errors in the device, we would most likely see a crazy spike or something that looks out of whack, in which case we will want to do some more digging into that specific frequency to figure out what it is that might be going on there. Luckily, my device responded appropriately during this test, so it looks like I'm ready to get approval from a manager to move on to the next testing phase. To learn more about how the FRA works and how it can benefit your testing, go check out my FRA Scopes University episode.
Next up, let's go to a live demo from a stream in 2017. That was back when the event was called Scope Month instead of Wave, and some of you OG viewers were there with us back then. Shout out to you, you're the reason we still get to do this event. Take it away. Every day in Scope Month, we also do a scope tip. So today's scope tip is going to be on the 4000X. Someone's asked in a previous video they put in the comments below a tip they wanted me to cover. They talked about having multiple status lines, and they wanted to trigger on whichever one of those status lines sent a rising edge. So there's a status line that says, hey, there's a failure here. It throws up a flag. And you can actually use it. What we're going to look at is an OR trigger to trigger on each of those status lines. And if any one of those go high, the scope will trigger. So let's take a look at the scope here. The first thing we see on the scope is that it's just free triggering right now. So I'm going to move my trigger level up just a little bit. And this threshold means any signal that crosses that threshold is going to trigger the scope. But even though there's no signal crossing that threshold, we can see that the scope is triggering because we're in a mode that's called auto trigger mode. And basically the scope says, hey, I haven't seen anything, but I think you want to see signal anyway, so I'm going to go ahead and trigger after a certain period of time. And this isn't necessarily what we want when we're looking at status lines. So we can put that into a mode, a trigger mode. Instead of auto trigger mode, we can put it into normal trigger mode. And now that I'm in normal trigger mode, you can see that my acquisition has stopped because there's no valid triggers. And when I tap on with this probe, I just tap on something, I'm going to start getting an edge and the scope is going to trigger, and it's going to hold that signal until I get another trigger. So you can use normal trigger mode, and we're going to look at normal trigger mode a little bit tomorrow also, for signals that are pretty infrequent, you're not getting a stable trigger under that normal trigger timeout mode. You can use normal trigger mode to get a stable waveform. But if I trap trigger 2, I'm not actually, my second probe, you can see this one's green. I have 2 probes here. If I tap the second one, I'm not seeing any signal because the scope is only triggering on channel 1. So I need to go in and change my trigger. And instead of being on an edge trigger on channel 1, I could go to channel 2 and go to a rising edge trigger, and now I'd see channel 2 triggering. But what if I have multiple status lines and I want to trigger on, any one of them that happens to go high? So you can go and do an OR trigger. And what this is going to do is I'm going to say if channel 1 has either edge, this could be a rising edge, falling edge, depending on how you've probed it and set it up. And I can go to channel 2 there, and set this to either edge. And now, if I tap either probe, the scope is going to trigger. And you can actually use this OR trigger mode on any of your channels. So you can do it on all 4 analog channels. You can do it on digital channels. So you could, on this scope, theoretically monitor up to 20 different status lines. And if any of them are throwing a flag, then you would trigger on that. And you'd know, based on where you probed them, which one of your status lines is throwing an error. So the OR trigger is a really nifty tool if you have a bunch of different triggers and you're trying to monitor and see what's going on. I also use them for debugging digital channels on my Raspberry Pi, which we'll look at tomorrow. If I just want to do a status check and make sure that I have my GPIO pins are toggling like I expect them to, that type of thing, I just hook up my MSO, put it in an OR trigger mode, set all edges. So if we go back to the scope real quick, if we go to set all edges, you can then set each of the analog channel edges and all of the digital channels to that setting there. Last up today is debugging GPIO channels with an MSO, which is super useful if you get stuck with your microcontroller. In this case, we're looking at a Raspberry Pi. Since it's Pi Day, we're going to use a Raspberry Pi for today's scope tip. I have a Nixie tube project I've been working on. There'll be a video for that in the coming months, where I'm using a Raspberry Pi's GPIO pins to connect to a BCD converter that then connects to the Nixie tubes. So the setup I have a breakout board connected to 4 of my GPIO pins, and I've connected an MSO cable to each of those 4 pins. This button should increment my GPIO pins by 1 in binary each time it's pressed. To debug my code, which I'm not going to post on GitHub to spare you having to deal with my coding, I've hooked up my digital channels 0 through 3 to the 4 GPIO pins that should be outputting a binary value. So to view those signals, I'm going to turn on my digital channels, and since I'm only using channels 0 through 3, I'm going to turn off 8 through 15, and I'm also going to turn off 7, 6, 5, and 4. Make those a little bigger, and now I'm left with the 4 channels that I'm actually using. I'm also going to turn off channel 1 because I don't need that. So now when I hit this button, I should be able to see my digital channels changing, which is helpful, but it could actually be more helpful if I could turn on a bus here. So I'm going to go back to my digital channels, hit a bus, and I'm going to turn on bus channel 1 and make sure that is assigned to just channels 0 through 3, so I'm going to deselect 8 through 15. And now you can see I have a binary value displayed at the bottom of the screen, and when I hit the button that should increment this code, I'll start seeing it increment in binary. I can also change the base value to hex instead of binary, and since it's for a Nixie tube, it should only show 0 through 9 when I press this button. I also want to debug my transitions so I can see how long of a period I need to set for debouncing. So I'm going to go back into normal trigger mode, and we talked about this yesterday, so check out yesterday's live stream to see why we're doing that. And then I'm going to set my trigger to be an OR trigger, and I'm going to set just all channels to either edge, and that's going to catch any edges on any of my channels. And now when I press the button, we should be able to see the transitions here. And you can see here it changes from 3 to 4, 4 to 5, 5 to 6. And you can see that my debouncing was a little too quick and I skipped a number there. So I'd have to go back, check this period in time, how long that transition takes, and set my debounce time for that period of time. There you have it. We're prepping over here to get this year's tips ready and make Wave 2020 an event you won't want to miss. Thanks for watching. You can find me behind the keyboard in the comments on all the videos on this channel, or over on Twitter at Daniel Bogdanoff. And right back here very soon, I have some big plans for these guys. I'm Daniel Bogdanoff, and I'll catch you next time. Go sign up for Wave.
The whole thing popped off.